Okay, good morning, everyone. And this is Benito Marcote from JIVE, and I'm delighted to welcome you on behalf of the organizing committee to the fourth series of the seminars sponsored by the European VLBI network, which focus on high-resolution radio astronomy. And this is the first seminar of this new series. We want just to mention a few logistics while I admit the last people joining here. So the logistics before we begin. So you will be muted throughout the presentation, but actually you are invited to type any questions that you may have for our speaker, Richard Schilizzi, today, preferably through the Q&A section at any time. Or if you are watching us through YouTube, you can also type the questions in the chat there. But then we will move to the question section right after the presentation from Richard. Please, we recommend you to write your questions clearly and try to keep them short. And in this occasion, we are doing through a Zoom meeting, so you can actually raise your hand if you want instead to make the questions yourself. We will aim to get as many questions as we can, but given the time constraints, we apologize in advance if your questions cannot go among those that we have time to answer. And from now, I will just give the room to Anna Bartedicit from the Institute of Astronomy, Nicolas Copernicus Interim, which will introduce today's speaker, Richard Schilizzi.
Thank you, Benito. Richard Schilizzi is Emeritus Professor of Astrophysics at the University of Manchester in the UK. He obtained his PhD in radio astronomy from the University of Sydney in 1973. Then he moved to California Institute of Technology, and next he joined the Netherlands Foundation for Research in Astronomy. That was in 1976. For many years, he worked on European and Dutch VLBI development, and in 1993 he was appointed as director of JIVE and established this nowadays well-known institute as the Central Data Processing and Support Institute for the EVN. Richard was also a professor at Leiden University, and in 2003 he became the first director at international level of SKA to build the world's largest radio telescope. In 2011, he joined the University of Manchester to establish an SKA group there and led design work in signal transport for the SKA. In subsequent years, he served on various national and international review committees and eventually took up a position as Emeritus Professor at the university in 2018. Let's start the seminar, The Great History of VLBI and His Story, the Richard's History. Richard, the floor is yours.
Thank you very much, Anna. Let me just share my screen.
Yes, please. Yeah, the sharing has started. We see your presentation.
Let me get into presenter mode, which I don't see now. Right.
Okay.
Okay. Thank you very much, Anna, for your introduction, very kind introduction. You did ask me to say just a couple of words right at the start about how I got involved in astronomy, and I usually think that's because I really enjoyed reading science fiction when I was very young, and the very first book that I can remember reading was called Lost on Venus. And that was written by somebody called Edgar Rice Burroughs, who was actually much better known for writing the Tarzan novels. But this was written, I think, in 1935. It was a long, long time ago. But that got me interested in science fiction. And many years later, at the end of my undergraduate degree, I went on a summer studentship to Mount Stromlo Optical Observatory. And that got me interested in astronomy. And I then took up a PhD position at the University of Sydney. So that's how I got into astronomy. People have very different ways of getting there, but that's how I got there. So I got a title here, which is a very broad canvas. And what I'll be trying to do is to just put a few brush strokes on that canvas that gives you an idea of the history of the EVN and JIVE and the SKA through the many decades that they've been in existence. Not just the history, but the people who were involved and some of the politics that went on as well that were very important in making sure these projects went ahead. So a couple of caveats. The first one from Hegel, which says the only thing we learn from history is that we learn nothing from history. I'm not 100% sure that's correct, and I'm hoping that that's not correct in terms of what we do in radio astronomy, and I'll come back to that later on. But what I certainly understand from my own experience is that human memory is a very leaky storage device. So what I say in this talk are my own views and memories of the things that happened during the development of JIVE and the EVN and the SKA, but it won't be complete. And so please ask questions, and after the talk or even later on, and I'd be very happy to answer them. Okay, these projects are big science and big collaboration, big international, actually global collaborations in both cases. Just a sketch of the overall timelines for the EVN itself. The first ideas were launched in 1975, and in 1980 the EVN as a network was established by the directors of the various observatories. As far as JIVE is concerned, the first ideas were in 1980, so pretty soon after the EVN got going. They weren't of JIVE specifically at that point, but more of a very large correlator. And you see that it took 13 years to get to the point where JIVE was established as a legal entity, as a Dutch foundation, and another 11 years before it became the European Research Infrastructure Consortium, so another legal entity. In the SKA's case, the first ideas were emerging independently in various places in the 1980s. 1990 was the first time that people really thought about a telescope. 93, a working group. 99, a steering committee. 2011, the first legal entity. And 2021, the crowning glory of an Inter-Governmental treaty organization for the SKA. And what you can see, I think, is in the EVN's case, it took only 5 years to produce an organization. In JIVE's case, it took 13. And in the SKA's case, it took a good 20 years between the first ideas and getting to a legal entity. And these are both science-driven, bottom-up projects, and they've evolved into the pillars of European and global radio astronomy. So we should all be proud of them. I'm going to show you here a brief history of very long baseline interferometry. And this is the only slide in which I have a full page of dates because I find them boring myself. But first, I think it's useful to get an idea because we are looking through the decades. So VLBI started in the 1960s in Canada and the US. And I've got pictures here, contemporaneous pictures of the people, some of the people involved from the US side and one Swede is Marshall Cohen, Ken Kellerman, Barry Clark, and this is Ola Rydberg in Sweden. That was followed by more observations in the US, and of course the startup of observations in Europe. And I'll get on to that in just a moment. The first discussions of European VLBI in 75. Some developments in the US for the Network Users Group. As far as Europe is concerned, in the 1980s, we formed the network in 1980 and a consortium in 85. 1990s is JIVE, and the VLBA began operations in 93. VSOP Halka was launched. First real-time VLBI via fiber was in 2000, or 2005, but started talking about it in 2000. Radio Astron was launched, and JIVE became a legal entity, European legal entity in the 2010s. So that's a very brief sketch of the development of VLBI with a real European focus, of course. But in parallel, I want you to imagine another timeline, which is the political developments in Europe as a whole. Post-World War II, there was a lot of effort at government level, but also scientific level, to generate collaborations that brought the countries that had been enemies before back together. And you'll be aware of things like the European Economic Community and so on and so forth. But there was also, CERN was developed in the 1950s and ESO in the 1960s. So these were genuine large-scale collaborations established by treaty, and it was the first evidence of international collaboration being used as an instrument of government policy in Europe. Those international developments just increased in time as we went on, and in the 1980s we had the start of the framework programs, and those continued basically continue to the current day. It's been a time of increasing European collaboration, both scientifically and politically. And one of the things that we've managed to do in Europe was to ride the waves of funding that went with those new ways of political collaboration. And I'll mention that occasionally as we go along. Okay, European VLBI in the 1970s. 1971, the first European observations. Jodrell to Onslow, you can see the fringes here. I'm just going to run through these things quickly because there are other things to get to. The first time that discussions actually took place in Europe about a European network itself were in 1975. The inevitable coffee table discussion, this time at the MPIFR, convened by Roy Booth, with Ivan Pliny-Toth, Eugen Preuss, and George Miley there, and there's pictures of them more or less contemporaneous at the time. This led to the first meeting of a broader range of interested astronomers in September of the same year, and then annual meetings after that. Nobody has a picture of either of these first two meetings. We do have one here of the fourth meeting in 1997 at Jodrell Bank, and you can see assembled group of luminaries here. There's Roy Booth there, Eugen Preuss there, Ivan Pliny-Toth in the background, various others who were people who were leaders of astronomy. I was there at the meeting, but not in the photograph for some reason or other. The next item I wanted to just bring to your attention is the first real European observations in terms of trying to produce an image. And these were observations that took place about 2 months after I got to Dwingelow in 1976. As the VLBI expert, because I'd learnt my VLBI at Caltech from Marshall Cohen and Ken Kalman. And we were observing 3C236, which was one of George Miley's favorite sources. And here are a couple of pictures of us. Can you see my cursor, by the way? I hope you can.
Yes, we can.
Okay, so here we are peering over the tape recorder, and we were in this cabin, the control room underneath the telescope. And we did a successful observation of 3C236. This is how the schedule went around in those days. It's handwritten. Here are the fringes we got out the end. Here's an image of 3C236 taken with Westerbork at the time. It's a giant radio source, 4 megaparsecs across. And here was our VLBI image of it at whatever it was, 10 or so milliarc seconds, 50 milliarc seconds, maybe, I forget exactly. And it lined up pretty well with the overall picture. And this was model fitting that produced this, this picture here. And you can't really see, but there's the model going through the dots there. Next point in the sequence of events was an ESA feasibility study of doing away with these cumbersome tapes, as you saw in that last picture, and using a satellite link. And that was using something called LSAT. But this was triggered by an actual test between a Canadian radio telescope and the NRAO 43 meter, led by Alan Yen. And this was successful and showed that actually it was possible to ship data from one telescope via the satellite to another and correlate the data. So we thought this was a good thing to try and do in Europe. And there are a couple of feasibility studies we did with ESA. And we made use there of the fact that Giancarlo Setti from Italy was also interested in VLBI and long-term plans for that in Italy, but he was also at the same time the chair of the astronomy working group in ESA. So we had a nice way of getting in contact with ESA so we could get a couple of feasibility studies done. And there, ESA was working on a large communication satellite originally named LSAT. So we'll come back to that, the ramifications of that in just a moment. MPI was the center of European radio VLBI, and it had a 3-station Mark II correlator started operation in 1978. Picture of Horst Blaschke, who was a calm presence in the correlator room for many years. This was followed by a decision in 1979 to purchase a 3-station Mark III correlator from Haystack. That was an important move by itself as well. Moving to the 1980s, the EVN was actually established, as I've said before, with annual meetings of directors. First one chaired by Peter Metzger from Bonn, and the EVN program committee was established with Ivan Polini-Toth as the first chair. And we don't have photographs of either of those events, the first meetings, but here are a couple on the right-hand side of later meetings of both the directors and the EVN program committee. It started, so 1980 was also the beginning of discussions of a new generation wideband real-time correlator for satellite link VLBI, as I mentioned. But after a year or two of discussions with ESA and their requirements of the telescopes having to build and pay for ground stations, it was decided it was too expensive for the EVN. So we went back to tape-based systems, of course, moving away from the Mark II systems to Mark III at that point. There was a proposal from Giancarlo Setti and the other directors to the European Commission to expand the Mark III correlator at Bonn, but that wasn't successful. But it did trigger further discussions in subsequent years about alternative proposals for such large processes. One was to upgrade the 3-station processor to 8 stations, which we tried before that again. And the other was to develop a new generation, much larger machine, user-friendly, at NFRA in Dringelo. And because there were these fairly large proposals coming out of the EVN, it was thought it was necessary to establish a consortium for VLBI in order to have a sort of a formal body that outside entities like the European Commission, could interact with. And so plans went ahead with trying to get some money from that. Here's a picture of the first formal meeting of the European Consortium. Members were Bologna, Jodrell Bank, Bonn, Tringolo, and Onsala, associate members you can see there. And here are the people around the table. Giancarlo Setti, who was the chair of the meeting, and the various groups sort of grouped by its institute or organization they came from. At this point, I'd been appointed the project manager for the consortium. And this resulted in we putting in a proposal to the European Commission for the first phase of a 20-station correlator. See, our ambitions were going up all the time as more telescopes were coming online in the EVN. That proposal was also unsuccessful, but a lot was going on behind the scenes. And there have been discussions with the European Science Foundation, with the Director General of Research in the Commission. We'd sent another proposal for 12 stations to Brussels that had been circulated to the European Science Ministries. At this stage, Brussels itself was beginning to move in terms of how they thought they could fund the way science was done in Europe, and they set up this framework program, which everybody will be, well, I imagine most people will be aware of. This was really focused on large-scale physics facilities like accelerators and so on, with CERN as a sort of model. But what this business of getting our proposals to the European Science Ministries did was that it got actual ministers themselves, particularly the Dutch science minister, starting to talk about VLBI with his French counterpart. And what this led to was an ESF report on European Science Foundation report on where VLBI lay in the list of priorities within ground-based astronomy in Europe as a whole. That review gave strong support to the processor. And what it did do was to lead the ministry, the Dutch ministry in particular, to pressure Brussels to provide funding for facilities like VLBI in the third framework program. And this is really important because the EVN was the first example of a distributed set of research infrastructures that actually worked together as a unit. And that was basically not on the scene at all at the time. So I think it's probably true to say now that a lot of the money that goes from Brussels to networks of facilities are distributed facilities one way or another. And so, yeah, we can all look back with pride in the EVN to having been the initiator for that set of initiatives inside of Brussels. So funding came for the correlator at last, not directly from Brussels, but with 1 million from the community for access to large-scale facilities. But the Dutch put aside money, and the French, and there was some support from the Swedish Wallenberg Foundation as well. And a year later, that led to JIVE being established as a foundation, with Roy Booth as the first chair. And then in the subsequent years, design, prototyping, and construction of a 16-station Mark IV processor by an international consortium. And that was part of a large EVN upgrade as well. So in October 1998, there was the official opening of the data processor. And here you can see the audience. Roy Booth is the chair of the EVN, the JIVE board again at the time. And here is the governor of the local province in Dringelo getting a lesson on how to hang tapes from me. He was looking pretty dubious. Just a couple of highlights here. Here are pictures of the first fringes a year or so before. from the correlator. The first science that came out on H1 absorption, NGC 4261. This is work done by Howard van Langenfelder. Here, the brains trust of the correlator design, Albert Boss, Alan Whitney, Sergei Pogrebenko, and Brian Anderson. And here are the operational aspects of it. A view that you don't see these days with the tapes and the tape storage device called the Paternoster. And just a picture, which I won't get into unless anybody's interested later on, of a flood that occurred in the Dringelow building about 10 days after the correlator was opened, and we were lucky that we survived that flood. Right, let me move on to the post-1998 activities very, very quickly, because I see I'm running over time already. And you can see the JIVE directors here. We've had a lot of radio astronomy funding from the EC from 1989 to at least 2020, when I stopped counting various of the logos of the different programs. RadioNet features multiple times in different contracts. We've had Express and Express. We've had other programs, including Scans, which is not in here, but you can see a few of the other logos there. In total, it's been at least 81 million euros have come from the EC to radio astronomy over those years. And here are the RadioNet coordinators over the 20 years or so, all familiar faces, so I don't have to identify them. e-EVN was another thing which was a real highlight in EVN history and JIVE history. That started in 2000 with a year or two of concept presentations to the National Research and Education Network. So they're the network providers to the to research net enterprises. That was backed up by the European version of that called JEONT, European Commission, various other places, just putting the concept, the idea of linking up the EVN with fiber. And here was our concept view of what it might look like in 2010. Of course, this turned into real activities after a test of the concept in the end of 2002. Mike Garrett, Al van Langenfelder took this on in a really big way and made it reality. And as you know now, it all can be linked up. So that's a fantastic step forward. And what I've been always a little bit disappointed in is how much the e-EVN has been used, but hopefully that will change as time goes on. In parallel, we had space VLBI. The first ideas were orbiting VLBI with Quasat, a whole bunch of studies done in ESA context. It was not chosen because it was too expensive. We tried again a year or so later with something called the International VLBI satellite. You see it over here. It was to be strapped to an unfoldable 25-meter antenna strapped to the side of an Energia rocket. Fantastic idea, not selected because the Russian funding was thought to be too risky. There's a story behind that, but I haven't got time to go into it. We kept involved in Europe via steering committees and so on in both missions, and also via the Global VLBI Working Group, which organized the ground-based facilities that work with the orbiting satellites. We also got involved with hardware, the 6-centimeter receiver for Radio Astron, which we built, but it didn't fly on Radio Astron for another story, which I haven't got time to go into. And finally, in this sequence, the Cassini-Huygens mission in 2005 was PI'd by Leonard Gurvitz. Very important role it played in being able to track the trajectory of the Huygens probe as it went down through the atmosphere down onto the surface of Titan. finally, JIVE turning into an ERIC. You've seen this picture many times. There's a proud Haub getting a certificate from Robert Jan Smits from the European Commission. Okay, let's move on to the SKA now, and VLBI moving very smoothly in many ways over to the SKA. It was a big global collaboration already, and it passed on to SKA the culture of successful international collaboration. It really set the scene for the SKA development in the 1990s. And the third point here is many of the people who grew up in that culture played and still play leading roles in the SKA. What's being built, as Phil Diamond likes to say, one observatory, 2 telescopes, 3 sites. A grand vision, it certainly is. There's the central headquarters here, next door to the observatory. Here's what's being built, the image of what will happen in both SK Mid and SK Low. Total construction cost currently for the first phase of the telescope, 1.3 billion. And you can see when the science expected to happen operational end of the decade and lasting for 50 odd years. It's a huge engineering and scientific effort, involving hundreds of people around the world. And many of you are probably involved in one way or another. A couple of slides of the construction at the moment. Here are the dishes, a couple of dishes being assembled. They're up to 6 about to be put in place in South Africa. Here's a picture of the low frequency array. You can see the drone vision, a view of it. A couple of elements here in the station that have been populated with these low frequency antennas. There's some first fringes with those, that pair of telescopes just a few weeks ago on Centaurus A. Success, and the observatory is on its way. The observatory itself is made up of many countries now. So there are 11 full members. There are another 5 that are awaiting entry, and you can see them here in blue on this chart. And there are conversations going on with another 9 governments. I think quite a few of them here in Africa. So this is a big operation, but what's interesting is there's no dominant national partner in this whole thing. This is a real grassroots effort. The 3 hosts, the headquarters and the 2 site countries, contribute most of the construction costs, but that's at the sort of 15% level. So how did this grand vision become reality? Well, you can read about it, all about it, in this bestseller, where you can get access to that at Springer and also buy it on Amazon. It's got a lot of detail in it, much more than I can cover in this talk, of course. So getting to where did the SKA idea start? There were 4 separate centers of the idea. It all developed independently. First, in terms of time, was in the Soviet Union, as it was. Yuri Parisky and his colleagues, starting in about 1960, started to think about very large radio telescopes. But we in the West didn't hear about that for decades afterwards. First we heard about these ideas was from Govind Swarup in 1980, but again, that wasn't publicized widely. Peter Wilkinson also developed an idea for a necessity for a large telescope to image or detect neutral hydrogen in distant galaxies, redshifts 2 or 3, in 1984. And again, independently, a group in the Netherlands from 85 to 89, Robert Brown, Geert Brown, and Jan Noordam. The light bulb moment for SKA actually happened in 1990, where the visions merged, more or less by chance, again over coffee, when Jan Noordam and Peter Wilkinson chatted over the future of radio astronomy at a meeting. And this led to a paper that Peter Wilkinson gave at the meeting, an ad hoc paper on the hydrogen array, where he talks about a 1 kilometre square, so 1 square kilometre collecting area for this telescope. And that's the start of genuine thinking about it. This led to the formation of a large telescope working group under the auspices of the International Union for Radio Science, chaired by Robert Brown, so one of the originators. And you can see there are 10 different countries involved in that working group. So SKA was born global. The working group vision for the SKA could be summarized in this way here, that we needed an angular resolution that was better than the Hubble Space Telescope, a field of view that was large, and all with a sensitivity of about 100 times the VLA as it was in 1990. So you can see what we're looking at. This is a plot from Ron Eakers, it's in the book, sensitivity versus date. And here you can see a list of, or a number of the telescopes, some of them in Europe. And what you can see as you go, but over the years, starting off with Reber's individual, he did it individually, then there were institutes, then national telescopes, then international, and here's SKA up here. And this was, this is a plot that was made in 2001, 2001. And at the time when, in 1993, here's the VLA that the SKA was being compared with. So that's 2 orders of magnitude more sensitive. And the reality is what's being built is over here, and that is less sensitive because it's 10%. That's the first phase of the SKA, and it's taken longer than anybody thought. And this is what happens with large global projects. We've done a bit of a study of what happens, and this is what happens. See, the speed of increase of your favorite parameter flattens off. So achieving that factor of 100 was not straightforward, but there were a lot of very innovative technologies that people were thinking about. And here's a few of them: Lüneburg lenses, a large adaptive reflector with the focus suspended under a balloon. There's a balloon. The fast concept in a karst depression in China. Low frequency antennas, the mid-frequency aperture arrays that were the idea generated in Astron and carried on for very many years. A simple dish in India, the Allen telescope array, and here a telescope that was the DVA-1, which was built during the SKA design studies, which was a carbon fiber dish, and focal plane arrays, again, which you are aware of via ASCAP. Some of these later developments were in the context of SCADS, SKA design study, PREPSCA, preparatory phase of the SKA, which was an EC-funded project, and the technology development program in the US on dishes, which was feeding into PREPSCA. There were technology down selects in 2005 and 2010. 2005 was to reduce the number of concepts that we had at the time down to the ones which we have ended up with SKA mid dishes and SKA low antennas. And there was a further one in 2015, which I won't go into. So you already know that that the SKA is complex. And here's a diagram on the right with year versus time, how the governance of the project evolved. And I'm not going to go through these in detail. The grassroots era, I've already mentioned the word grassroots, so that was when astronomers and engineers were in charge. Transition era when the funding agencies began to be involved. and pre-construction period and the construction period. If you look at this just in general, multiple nations, multiple players involved, and all of these with different funding cycles and cultural approaches and so on, different research institutes, large and small, industry, government funding agencies. And as soon as all the government funding agencies got involved, the scientific community was no longer in sole control, and it's expensive. And the glue for the SKA was the overriding grand vision of building the world's largest telescope. But it's still amazing that it worked at all, particularly with no dominant partner. Almost all other large facilities that have been built with a dominant partner from within an existing organization. So here's the same diagram again. I'll just say a few words about the transition from grassroots into this more complicated era. And the reason was that we thought it was time to get the funding agencies involved. So we approached them and told them what we were doing. And they said, yeah, you know, all those 7 different types of telescopes you've been working with, that just indicates to us that your project is immature. Come back when you know what you're going to build. And also, just by the way, your idea of actually selecting the site for the telescope in 2006, nah, you guys can't do it by yourselves. We have to be involved, and the funding agencies have to be involved. So we went away and changed things very quickly. That led to the first down select on the technology, and it led to the change in our strategy about site selection from a genuine one site selection in 2006 to a shortlist. So in this era, the grassroots era, it was driven by key individuals, and you talk about in the transition era, we lost our innocence because idealism gave way to pragmatism as all these different organizations became involved. So here are a few pictures of funding agents, the steering committee's funding agencies group, the people involved in the central project office that I was director of by then. And here are pictures of the SKA organization board that was formed in the end of 2011, and the picture of when the convention signing took place for the Observatory Council, and just a final picture here of the 3 people who have been the directors of the telescope. Me starting in 2003, Michiel van Halem, who was an interim director for a year before Phil Diamond took over in the end of 2012, and Phil was still there as director. Right, it wasn't all plain sailing, as you can imagine, with all that complication of the different agencies involved. And the main challenges we faced then were funding approval. We had to get onto various roadmaps. In Europe, there was PREPSCA and Astronet. There was also something called ESFRI, the European Strategy Forum for Research Infrastructures. We managed to get onto those, and that was really important for getting the funding agency co-ownership of the SKA in Europe in particular. I mean, that was the brilliant thing about the European Commission and their preparatory studies like PREPSCA, is that the funding agency had to be the coordinators of what they call the policy work packages, which was the governance, the funding, and the industry engagement. And the other important roadmap was the US Decadal Survey, which we put a proposal in. Well, our US colleagues did, but we had a lot of involvement in it, which was not successful. And I don't have time to go into any more of why that was the case, but if anyone's interested, we can talk about it. But we needed luck in all of this. We were there in time for the first round of these preparatory studies, and so we could ride that particular wave. Site selection was, as you can imagine, with a short list of Australia and South Africa, it was tense and political, got right up to the top layers of President and Prime Minister of both countries, came under the funding agency control from 2010 onwards. I've got a slide on that in just a moment. The engineering design, as you also can imagine, difficult to manage. No one had been involved in a project of SKA's scale or cost before. And of course, the form of governance to provide a stable environment, because we didn't have a home environment for the SKA and had to invent it. Okay, site selection. Started in 2002, so it was actually a 10-year process because it was completed in 2012. Got to shortlisting, and here are the 4 sites, which so it's Australia, South Africa, South America, so it was Argentina and Brazil, and also China. And what you see here are some of these pictures you won't have seen unless you've looked in the book, is pictures taken by Rob Milinar of the sites. They're really quite spectacular pictures. Australia, Argentina, where the core of the SKA was going to be, South Africa, and one of these karst formations in China. Okay, so the site shortlisting left us with Australia and Southern Africa. We had some site characterization, mostly RFI measurements. Proposal, evaluation, site decision took place 2010 to 12, and ended up with the adopted solution decision was that the site would be in 2 places, or the telescope would be in 2 places, South Africa and Australia and New Zealand. New Zealand was involved at the time. For the full array, of course, we were still talking about the full SKA, and for phase 1, which was seen as the way into producing the full array. And so we had a mid-frequency dish array in South Africa, low frequency in Australia, and what was called the survey telescope with phased array feeds in Australia. Okay, what I didn't tell you about in all of this is the international national stories about how and why individual countries got involved or regions got involved, our over-optimism about timescales and costs at all stages of the project. I mentioned why the US isn't involved, or any details of the final site decision. So lots that I didn't talk about. It's been a fairly whirlwind tour through the whole deal. You can read more about some of this stuff in the book. And I want to end here with my acknowledgements. First of all, to Richard Porkus for a fantastic history of the first 30 years of the EVN that he gave 2010, which you can read about in this link. And Richard's also been very useful in me preparing for this talk, and various others who've contributed either slides or information or advice are listed here. I won't go through the names. You can read them. Many famous astronomers involved. And so I'd like to end. Thank you very much for your attention.
Thank you very much, Richard, for the great historical review. So thanks for the talk. Now it's time to open the floor for any interesting comment, questions, discussions that people may have, for sure, after this great talk. So as a reminder, you can either place your questions in the Zoom Q&A section. You can also raise your hand, so we will allow you to do some questions, or you can type it in the YouTube chat if you are there. And we will try to address as many questions as possible, but then we cannot guarantee to address all of them if you are if we have running out of time. So we can start with one that we have from the Q&A from Pedro Augusto, which is like, what do you mean, Richard, by that the e-EVN is underused? So is there any particular reason why you expected
that's an interesting question. So what I had in mind the time was that we'd actually switch off tape recorders, and we do it all via fiber, and where there would just be a switch between VLBI via fiber and whatever the local telescope was doing. That was the sort of idea I had, and so, yeah, reality is always always different. But it is a fantastic system, and of course it is going to be absolutely the basis of the SKA, and that's why the EVN is a pathfinder for the SKA.
Yeah, great, indeed. And now the two systems kind of live together in the EVN for years already. Like we have many astronomers like getting advantages of the real-time EVN, but still we have the test recording. So indeed, that would have been a really good dream. Any more questions from people? Okay, we have one from Kiran in YouTube. Thank you for the very interesting talk, Richard. One question is like, why is the SKA headquarters in the UK if the telescopes are in South Africa and Australia?
That's a really interesting and very good question. It's partly because the UK was interested in playing a major role in the SKA. And when you get governments involved, they want to see some return for that interest in their own countries. That's how you sell the idea. And the project office had been, the central project office had been in Manchester at Jodrell Bank. No, well, first of all, sorry, in Manchester and then at Jodrell Bank from 2008 onwards. It was originally in Dringlow, and then moved to Manchester, and I moved with it. So that's partly why. Well, it is the main reason why the headquarters are in the UK. There was a competition. There was a competition for the project office twice, in fact, in 2008, 2011, and again in 2015. I hope that answers the question. Oh, and just by the way, one other question is, if you had the global headquarters in one of the two countries itself, it would be inevitable for the whole SKA to be regarded as a sort of a national telescope of the country where the headquarters was. That was part of the thinking.
And that's how it makes it a completely global.
The way it is makes it completely global, yeah.
Okay. We can continue with one question. Is, do you think that the development of the NG VLA can impact the SKA? That's competing.
Could you repeat the first part of the question, please?
Yes, like how does the NG VLA development impact into the SKA progress of development?
Well, I'm aware that there's a lot of conversations between the directors of the SKA and the NRAO, just trying to work ways of making the collaboration a very profitable one. Of course, there's a frequency distinction between the two. NGVLA is high frequency, and the SKA is lower frequencies. Of course, there are ambitions to go even up to 25 gigahertz beyond the 10 gigahertz that are currently thought about in band 5. I think 10 to whatever, 10 to 15 or so. They will coexist perfectly well and feed off each other, I'm sure. I mean, it would have been great if the US had continued to be involved in the SKA, but as I said, there's a story attached to that. I won't go into that unless somebody asks me explicitly.
Thank you, Richard. And actually, that allows to have one in the south and one in the north hemisphere, so they can complement.
Yeah, indeed.
And actually, very interesting question from Daniele de la Casa. Based on the history that you reported in your talk, the question is, what's next after SKA? What do you think that will be in the future after SKA?
Hello, Daniel. I haven't seen you for many years.
Hi, Richard.
We give a little bit of thought to it in the last chapter of the book. I think that it's going to be difficult to get the full collecting area, but because that's a factor of 10 above what's being built at the moment. It's very clear that the SKA phase 1 is going to have to be operational and showing fantastic stuff before you can move any further with that. And really the only thing to increase sensitivity is by increasing the collecting area. Of course, there'll be a lot of innovations in the receiver technologies and sort of the auxiliary instrumentation, and those developments are going to be driven by the national institutes, and that's one of the reasons why we absolutely need to maintain the national radio astronomy institutes all around the world to start off those developments, which can be adopted by the SKA. Of course, supercomputing, quantum, bringing in quantum computing, that will be something that comes along, we'll benefit from. And who knows what else we can do. We're looking at a 50-year lifetime for the SKA, and the only thing that is that for the telescopes that we have, is that all the major discoveries that are made with them were never written up in the proposal that got the funding. They were thought of afterwards. And this will be the case for the technical developments as well for the SKA. Now, I'm certainly optimistic that something will come on to follow on. But what it is, I don't know.
And partly related to that, from Salt Paragi, how you see the chances of getting a full SKA with baselines of thousands of kilometers, like getting a really full SKA, longer baselines even?
I think that's an incremental change that could actually come about, because you can think about installing, as we've done in the EVN, installing telescopes at very large distances, and then sort of gradually filling in the gaps in between. And I could see that happening, because of course in South Africa or in Southern Africa, that was part of the proposal, was telescopes in Madagascar and Mauritius, and going east-west and going north-south, or going north anyway into the other African countries. And that's what the African VLBI network is starting to try and exploit. And at low frequencies, and of course, there are good reasons for having long baselines at low frequencies for the H1 absorption at high angular resolution. So I can see that sort of thing also coming along, and I know that there have been some ideas inside of Australia already for that.
Yes, thank you. And in any case, for now, at least, we will integrate with the existing VLBI network, so there will be a mix of the first years.
Well, of course, yeah, I didn't talk about,
of course. So,
yeah. I didn't talk about the use of the SKA as an element of the larger networks. I mean, I think that's a fantastic idea, and I'm glad to see it moving along well.
Then we will conclude with not a question, but it's actually just a personal thanks to you, just in case you don't see, from Eugeniusz Patensky. You may know because he did many times in Dwingelo to build the low noise amplifiers for the 50-meter antenna in Toruń, Poland, in the beginning of the 80s. So he congratulates for the VLBI community that you were building there.
Thank you very much. Yes, I remember. Yes. Good to hear from you.
And then with that, we will finish the conclusion as we are running a bit more of time. I will just finish with a last quick announcement, which is like the next EVN seminar will take place in December 12th. And our speaker will be Cristina Nancy from INAF Bologna. And she will do a seminar and showing the connections, the tight connections that are between the two streams of the electromagnetic spectrum. So from the radio and VLBI in particular, and how that one actually allows us to understand what happens at the very high energy gamma rays. And just as heads up, so we haven't finished the time for the seminar, but it will be on the 12th of December. And just as quick head-ups, JIVE is organizing a school on VLBI in the fall of 2025. So the final date is still to be confirmed, but it will take place in a hybrid mode with 2 physical hubs where participants will actually attend in person. One will be in JIVE in the Netherlands, and the other one will be in Pretoria in South Africa. So we are actually making a very long baseline school there. Still, we cannot provide more details, but then you will hear about it in the coming months. So stay tuned and then prepare all students, people that wants to initiate on VLBI and data reduction. This will be a fantastic school for that. And then with this, we can conclude the seminar here. Thank you, Richard, for the great seminar and everyone that participated and provided all the questions. Has been a really great discussion and historical review of that. So I hope to see you all in December in the next seminar. Thank you very much.
Thank you.
Thank you, Benito. Thank you, Richard.
Thank you all.
Thank you all.